Welcome back, guys. So today, let's see where we left off the week before that. I guess last week I was not able to stream. I was in a company trip to Austria. I was planning to stream there, but then the internet was so shitty there, so I was not able to stream. Well, it's fine. I guess we can continue where we left off this week. I just have to recall what we did because I have no fucking clue of what we did because I'm completely shut off from this because it's been 2 weeks. I believe we left off somewhere around just getting the initial setup, that is the block structures in place. We designed, I mean, like we initialized all those structures init with your registers. Yeah, we updated all the registers with values, and also we initted the queue. Here we have I think this is the step that it registers. Yeah, we set up the queue register. I guess this is also, we did something after that about, maybe guess maybe it will be in the k-main. Let's see. Yeah, we made the virtual block requests. What else? I guess I'm completely off here, but I believe this is where we left off, somewhere around this. Let's just piece up things together from here and then think about what else. If we have did something else, we'll eventually figure it out. But yeah, overall, so to give quick recap, so we are writing our own kernel, and we want to write the file system for our kernel, and then we started off by looking into how the virtual file system layer works, and then we went into the block layer, and then we thought about the actual physical thing, that is the, which in our case is which IO, and so the block layer is gonna connect to the which IO layer, and that's how the entire transaction is. Then we went through the which IO specifications. We had some issues with switching between which IO versions, and then we managed to get past it. Now we finally able to actually register ourselves as a driver to the device, and also get the length of the queues, and also register a queue. I think that's all done. I guess this is what we have to do. Prepare the request to write, and this is the final example that we want to accomplish. And after, we can build on top of this example to fill in the gaps. But right now, we have to send a request to the which.io and see if it send a write request to the sector 100. Put that in the queue and notify the registers and see what happens. And this is the bar register I wanted to try out. And what the fuck is this? Is it like this? Is that even a valid statement? This is also valid? Okay, whatever. Let's because right now, because I don't have any information about where I left off, it's a bit little hard to think about where to start. Only thing I remember is that I remember actually looking into the structures and flow of how to chain those descriptors, because from what I remember, every descriptor will actually have, let's just check it out. Yeah, every descriptor will actually have an address, and this address should be a physical address, and this address should point to whichever value we want to give in, and we have to chain them together. Like let's say we want to make this particular request. First of all, we don't make this entire thing as a single request. We have to uh, allocate this and not allocate this data part. Data is not needed. We allocate this request and we take the address of this and we create a descriptor for this and we put it into the descriptor queue, and then we create a new data and take the address for it and create a new descriptor, and put that into the queue. That's how I remember it. Let's just maybe we can see how it is done. Visualize which IO descriptor chaining. We want to see which IO 101 and descriptor chaining. Structure memory layout ASCII. Okay, let's see how it is. Okay, so so yeah, this is what we wanted to be, because we already have this descriptor and it just has address and length and flags and next. So if we want to build up the memory layout on how this structure be placed in the queue, in which IO queue. I think we have to see it because I vaguely remember the idea, but I want to see how it is. Okay, I just need a descriptor to give me ASCII out of how the layout will look like. I want to see it. I want to fucking see it. Exactly. We prepare the structs like this, and we also set the next pointers and set the flags, set the length, and we also pass address. I guess flags will give us okay. We set flags as next. If we set as next, then it's like a chained thing, and when the final node comes in, we actually have the operation that needs to be there. So ASCII flow and write for write operation to block 100. So within the descriptor, this is exactly what I meant. So with we create three different structures of the same which descriptor, and in the first descriptor we just put we allocate the header is just probably this, which is the type reserved and sector, and then we chain it to next, and the second index it's going to be the same what is it which descriptor, but in this case we also have to add the address as the data buffer, which is the actual data we want to write, and the third index is a status byte, which will be updated by the device to notify the driver. So descriptor 0 points to the requests, and descriptor 1 points to the data buffer marked as next and write, and the status byte is marked as write, so the device will write that will return the result code. Okay, now we get it. So after we put all these descriptors chained and we update the avail ring with the starting index, I think so. After setting the chain descriptors, it's within the descriptor table. Driver updates the avail ring with the starting index, because this is already given in the specification. We could just see it here too. Let's go to some device. Where is it? Let's just check requests. See if we can find it. For some reason that's not there. Let's just check for this then. Okay, whatever, but in general I did remember seeing it somewhere here. Okay, if we have to find that now, it must be here because I remember it. This is the which queue initialization, and this is how we prepared this this particular function, that is to set the which queue. This is the exact algorithm they have already given it, and we did the same thing here. And so this is driver initialization. So what happens after that is the actual transaction, which is the doing either some write operation, read operation, or whatever it is. Device operation. That's for a different device. Let's see if the device operation is available for block device, because that's a network device. Must be, yeah. Now we have the block device, and we have the feature bits. We finished these steps last week. I don't know if we managed to finish this part, but I feel like we did. Okay, we have the device operation, and which is the BLK request, and this is how we figured out what needs to be there. I think there's nothing specific. The device operation itself is just, it's a user specific thing. Maybe that's why they did not give any information about it, because after device initialization there's nothing much there. Maybe. Let's see if we can find chaining. Chaining seems to be a bigger. Okay, whatever, let's just assume that this is how we wanted to chain it, because I'm not sure, but I remember taking notes. I hope it's somewhere here. Oh, it's here. Yeah, this is what I meant. So inside the virtual descriptor queue, we write multiple descriptors as we saw here, and every descriptor will take an address and a flag. The address has to point to the actual thing, in which is, in our case, first one will be the request header, and the second one will be the data buffer, and the third one will be the status byte. Create the request with type and get the physical address of the request. It should be a physical address that is placed here, and then create a descriptor with address and chain to next. Create the data, get the thing, increment the descriptor base address plus the bytes used to go to the next descriptor. To put the descriptor starting index into the avail ring and notify the register. Notify which register? Here, register. Maybe I should have properly documented it. No, yeah, we'll see. I think we'll have to notify queue notify. Let's just put queue notify here. I think that is all. Let's just start the actual thing here. And do we have the actual, because we have to write it into which register? Descriptor, and descriptor is this. We write into register, we write into this physical which queue descriptor. Lower half and upper half. We initialize the address of the descriptor queue inside the registers queue disk low and high. So we just it's a physical, and inside that we also have the virtual memory, so we can just write to the virtual memory and device will use this physical, right? I think it's just a stupid question. I just want to confirm, because in my virtual memory I have something that is pointing to this queue's physical address. So I use my virtual address and write something to the queue, and the device will use the physical address to read from the queue. Yes. I simply write to this address. No, the virtual address of this, and I have it stored. Okay, so let's go back here. I think we want to write the actual setup in the k-main and keep the implementation details off. So now we have the requests. And let's allocate it in this heap, so we can actually get a proper virtual and physical address. So we'll use our kmalloc, our infamous kmalloc global map, and we want size of, what is it, size of which IO bulk requests. And data needs to be the same. We need kmalloc, because only then I can actually get the virtual and physical conversion easily. If not, if I put it in my stack, I can't actually get my virtual memory, because I don't know where my stack is. Let's put size of, we want to write 12 bytes. Let's put 16 bytes so that it's 4 KB lines. Data of 0 equal to t We have an even better way to do it. But I just landed recently. And just put data of I plus I, right? Or I plus plus. I need post increment, not pre-increment. Post increment in C. So it's I plus plus. Okay, this is what I want. And put it to T. And then I just put this TE. Yes, T. And I don't need this. And let's just put /0. Okay, now we have a string that we can write. It's just test. And then we have the request, and let's fill up the requests. Requests that we don't have to write data received equal to 0, I guess. I don't know. What was the reserve? Why do I have reserve? There's no fucking reserve here. So let's not write that. Oh fuck, this is requests. Requests is a different struct. Which VLK rec. And we do have reserved here. First there's type. Put the type here. Which out, right? Yeah, it's out. That means right. Rec sector. This is going to be 100. And then we have reserved. I guess reserved. Let's just put 0 there. I think it's just 0. Now we have the request ready, and then we'll have to, what else? We have the request ready, we have the data ready, and we need a status bit. I think we can, now we just have to prepare 3 descriptors. So it's going to be which struct, which descriptor star descriptor 1 equal to kmalloc, and it's going to be global, and sizes of is going to be, what is it, which IO descriptor. Okay, let's just copy it. We need 3 things, and the first one is going to be the first descriptor, and the second one is going to be for the data, and the third one is going to be for the status bit. And if we come back to our example, we can actually see it. I guess this is more than enough. Now we put the descriptor 1 dot address as Virtual to physical. Do you have some helper like that? Because I need to convert virtual address to physical. I remember having an helper like that. Must be here. Map user to physical. I don't want to map because it's already mapped. I simply want to I think this is that because it's taking a virtual address and it's zeroing the upper bits. So this one actually gives the physical address. And what do I need? I also need the physical address. So I think I can just use that. The naming was so fucking bad. I have no idea why I named it like that. And the first descriptor would be the request. So we'll just put request. And it's this address, and we are getting the physical address for it, and we are storing it there. And then we can take the descriptor 1 and length. I guess length is just size of. What's the length actually? Should I give the entire length? Probably the length of the requests. And then I have to put descriptor, dot flags. Currently it's just going to be next. Next. And then we have the descriptor 1, which is next. Next one should be 1, because this is the 0th index. And now I can just copy the whole thing and put it here. And append or insert. Insert. Oh no. Okay. Should be 2. Okay. And this should be 2, and this should be data, and this should be also data. Here we also have to put next and which I write requests. Now we again take the entire thing and put it here. I have 3, and here what do we put? What's the tag value? I guess it's some status bytes. Is status byte some sort of what is it? Structure? Or is it just the integer value? I'm not sure. The third index descriptor chain, which is status byte. Is it a struct or just int value? I need to know that. Okay, so it's a uint 8 value and it has 3 possible outcomes. So I have to allocate a uint 8. Is it even possible? I mean, it is possible. Uint 8 star status. So pass physical address for uint 8. Okay. Or maybe because it's a simple simple structure, maybe simple data type, I thought maybe we can just pass it as value instead of pointer, or maybe I don't know. Okay, whatever. So if it's status, so I put kmalloc and it's global and size of uint 8. Status byte and size of uint 8. Okay, the issue here is that I think I have to give the size of the internal structure, not the pointer, so this is wrong. Maybe I should give it like size of requests, and this is just 16. And here is size of uint, this is correct. And here we just write because there's no next. Okay, now we have 3 descriptors. Now we can write it into the actual queue. So this is our virtual queue descriptor. So it's like which queue descriptor objects. Wait, that's something I wanted to check. Here I'm allocating which queue descriptor and it is of size which queue descriptor into 12. So I can store up to 12 descriptors. So I think I can just take this address and add the size and get to the next ones. So it should be fine. So it will be like okay, we'll use that version. So it's just which object? What the fuck is that? Virtio underscore objects. So here I have the avail. This is a U16 value. So what I do is that I make like this and plus I equal to 0 and it should be size of what is it, which IO descriptor fucking not this, what the fuck, descriptor into I'm using the same method. It's just size into I and this is the base address and I can get this U64 value and I can struct which descriptor star. Now I have the actual descriptor and I can take it should be I plus plus and it's equal to descriptor 1 well if I have already allocated that much space there, why the fuck did I allocate it here again? Oh fuck me, where is it? Okay, I have descriptors and I have space for 12 of them. Maybe I don't need it. Maybe I don't need it. So that's the thing. So the descriptor register, we pass a base address and that base address is of which descriptor queue. So I think it's correct, we don't need this. what we need is to put this into that. Holy fucking moly. Okay, we lost it. Whatever. So the idea here is just to update these three values with the actual thing from within that queue. So it would be like I take the virch.io objects and virch.io descriptor base address, virtual base address. And I convert it into struct virtual descriptor star, and here I just put this size of struct virtual descriptor into I++. I think that is it. Nothing much. We have the descriptor base table base address, and we get the size into I, so it will be 0. So the first one will start this plus 0, and the second one will start this plus the size of descriptor, and the third one will start with this plus size of twice of this. So I think it should be fine. Hopefully, I don't know, I guess it's fine. And here, as we can see, the queue has already allocated the memory, so we can use that and just update the things. And finally, once we have updated all the queue, I guess we are supposed to update the what do we update? I don't know. We have the queue, we placed all three descriptors into the queue. Now we update a register. What is that register? I guess we wrote it somewhere. We in queue notify. No, we also have to put the index into avail ring. Okay, let's put that. So we get the virch.io objects, and we take the avail. And what is this avail actually? Virch.io with q avail. It's a structure, so we have to make it like a structure. So what does that structure actually want? I think even there we have already allocated it. Yeah, we have already allocated that too. We can have up to 12. So let's just take the first one and then put a which queue avail inside it. So it should be which queue avail object. Which queue avail objects, and we set index equal to 0. And we set flags. What the fuck do I set in the flags? Okay, want some routes, scripters to the queue. What should I write in the, okay, what should I, instead of like, what is the value that needs to be updated in the avail register? What the fuck? What is a ring? Explain. And ASCII. ASCII memory layouts. That's avail. So we have the avail ring. Maybe what we call as avail ring is just this. Oh, no fucking clue. What do you mean avail ring? I have avail objects and I have used. Let's just recap it. We have avail, descriptor register, avail register, and used register. We update those with physical address. My avail is a struct. So what do you mean by avail ring here? Let's see. Okay, so this avail ring is just referring to the structure. So we just write into this structure. Okay, we have these, and do we have a ring? No, we don't. Oh, we do have a ring. Okay, we have a ring. Okay, so what do I update in the index and ring field of my avail struct? Wait. Let's go back to our avail ring structure. Okay, we have possible of 8, 48. Okay, then it makes sense. I can simply so the thing is, so I have to update the ring index with the update the ring index with the index of descriptor and increment the index field. Why the fuck do why is it designed like this? Why is it just not update the index field with the current index? Because it does not make sense for me, because if we have a avail ring, why not just update this index with the value of the starting index of the descriptor? Okay, so because right now if I update the index with directly with just one index, that means then there can be only one query at a time, and until that query is processed I cannot update the index. Now because this is multiple, I could just update the ring with as many as indexes, and then update the total index and increment the total index so that I can have multiple batched chains. Okay, makes sense. To take the ring array with the index of the index of the descriptor chain, and then increment the IDX fields. This way multiple chains can be batched together. Okay, makes sense. So what I have to do is that I set index is equal to 0, and I take HIO avail object IDX, because that's the current index value, and I update that with the descriptor chains index, which is just 0, and I don't have any flags, and then I update and then I increment it plus equal to 1. In the next operation there should not be 0, because this is my first attempt. I can set the value to 0 and then use that index to actually set the ring index value, descriptor chain index value, and then increment the index, because currently we have added 1 value, so it should be 1 here. So the next time 1 will be used here, blah blah, but it does not matter still. But I'm just trying to understand why is it designed like that and what is the actual use case. And it makes sense that if there's multiple batches that needs to be processed, we can use it this way. Okay, now we have returned to the ring and we have incremented the index. Now what do we do? Probably we'll have to I guess we'll have to maybe, let's see. Yeah, we can just now update the which queue notify register. Do we have this register here somewhere? How do we notify? Why is the squiggly bracket here? Why is there a standard rule here? Oh, it's here. Okay. Whatever. Let's just now we have to write to the register, and so that then maybe we need the base address, and the base address is supposed to be we just take write U32 and we pass the virtual object and the register. Okay, 32, we take the virtual object and the offset would be virch.io, right? Yeah, virch.io q notify. We have q notify, and the value is, what should I write? Okay, after writing to the avail ring, to notify the which what value should be written into the queue notify. Let's just say take that. So we have to write the device specific queue. Which specific queue was the new available? Okay, we want to write the index within the queue. I think it's 0. I don't know. Well, let's just check it. During initialize queue, we select queue as 0. Okay, so it's 0. I think that is all. Nothing much. Let's just see. We have 9 fucking errors. So let's just get through them. Whatever. We get this. Okay, we just we have to cast them, or our compiler won't know that. Where is it? Okay, we here put the cast is a charge star. I think we'll have to do the same for here. It should be struct. And we also have to do this here. Status uint 8 star. What else? I guess that's it. This should have at least reduced 3 errors. And we have 6 more of them. We have 8 more of them. Okay. What is it? Okay, we have 3 different definitions of int. Well, let's then just remove this. Should be good. Okay, what else? Now we have undeclared fucking identifier, which, okay, I have to put struct there because it's not type def, it's structs. Okay, that should do it. Now we should only have 7 errors, or 6 probably. We only have 6 errors. Okay, what is it now? It's size off. I just put size. Fuck me. Where is it? Line number 30. Oh, sure, size of 3032 3000 and 300. I think that's a different error. So let's just build this, and now we have just 4 errors. And it should be, why is it incomparable type to, okay, you want it as uint 64 value, just convert it into uint 64 and also convert this into uint 64 so that both will be compatible. And we only have 2 errors now. It's the same fucking size of, we just put the proper it's the line numbers 304, put a struct here, and what's the next error? It's for status. For status 2 I just put the same uint 64 because I'm taking the address, I'm not taking the value. And we are done with it. I don't know if anything happened or not. We stopped around allocated done. Is that where we stop usually? No. What? I think we move past this value. Unit 10 which I ever. Do we have that message? Okay, we do have that message, but okay, let's just, so that it will be easier. After that, we have a where are we? Okay, we have init done. Where did we stop actually? And then we are just trying to actually make the request work, right? So maybe it simply worked because there's no, but we do have other print messages. Maybe we failed somewhere else. Okay, it's going to be 1 and it's going to be 2. It's going to be 3. It's going to be 4. It's going to be 5. It's going to be 6. Let's run and see where did we stop. Looks like we managed to finish everything. And we did not stop at all. Okay, so we did notify Q. So what do we expect? Either we have to read the register and see if the operation was successful, or we expect what is it? Interrupts, I guess. Okay. Oh, fucking hell. Oh, fuck me, I should have put here. It is test. This is for testing, but that's not what I wrote. Definitely. So let's write K A I E N. Let's run it and see if the fucking thing worked or not. I mean, if it wrote somewhere, it must be there. No, it's not that. Let's just put strings. Yeah, it's not there. We only have these strings. Python code to open a ext4 image and read sector 100. Oh, okay. Let's just use that example to just so that we can actually test if we have actually written to it or not. Okay, yeah, we test ext4 write.py, and we just have to put this. Why the fuck is it this? Maybe I should put fuck me. Okay, it's not going to fucking cat tests. I fucking forgot what to write. Let me just put in this. Is it UF? I paste it here and put it here and say UF. I have to fucking remember how to write it into a file. I think this is the best case scenario we have now. And I have to just live with that alignment. Will it even run if the alignment is like this? Okay, and see, actually we could just simply read to that offset and we can get it, because that's exactly even we are writing. So even without installing this, we could just simply write it. But yeah, we can install this and make it a little bit better so we can actually know what it is. Python 3 pip install ext4. That's it. This. Okay, that's not possible. Then why the fuck did I just install it? Fucking piece of shit. Why the fuck it's not getting killed? Test ext4 write.py. Let's just seek mode here and print. We have data, which is a sector data. Okay. We have to change the file fucking name itself. X4 image. I copy this and let's get here and let's just say img equal to why the fuck does it is not working? It does not like it. Whatever. This Horizon 3 test. It's just bunch of fucking zeros. There's nothing there. So definitely it did not write any fucking thing. Maybe we have to after we notified the device with q notify register, which in my case is index 0. Next step, how do I confirm if the operation passed fails? Okay, we can typically sign by interrupt, or you can poll the uString index field. Okay. Okay, let's check. Modify, and we have to wait for a while. So let's wait for less than. This should also be just too easy for it. Maybe probably a few milliseconds. I plus plus. And then finally we just print printf status bit d. Well, I'm using d. I don't have an format specifier for that, so yeah, I only have this. I have to dereference it because status is pointer star. Okay. Okay, now let's bash builds. I just have to put the proper let's build it. Okay, we have 10,000 increments. Is it too much to ask? Why is it not done yet? It's just 10,000. I thought it would only take 2 milliseconds. Currently the status bit is 0 and it's taking forever. Okay, maybe then I'll just reduce it. I have no freaking clue why it's taking 50,000 then. And then the status bit is still 0. Fuck me. Wait. Maybe it's not even updated in my case because it's just having the same value. Because let's just confirm it by updating the status bit with some random value. Hopefully that does not. See, it's still the same. It's not updated. It's just fucking with me. Okay. Okay, how do I debug this? I don't see anything happening. There anything in camel logs? How do I check if made proper request to the child? Okay, let's start with the camel log then. Remove that and bash build, run it, kill it, open the fucking demo. Okay, what are we looking for here? Any errors? Okay. There's no errors. Is there any far? Like, then let's tail it. Tail 100. I think I should just use tail, not cat and tail. That's not fucking with this. Tail issue 100 and there is nothing. It's simply almost every operation is just happening there. If we put 10,000, do we see anything? It's just execution state. There's nothing here. Okay. Now how do we think about it? How do we handle this case? Either we have to go through the initialization process one by one in the memory layout to see if everything is in place, or we'll have to, I think there's no other way. I have to manually check if everything is there or not. I think that's the only way. Maybe we are not reading it properly. We have written how do I run this while the camera is run Kernel. Okay. Mac. Maybe it will be Command Shift. I don't have an alt. Fucking. Okay, I just put that. I run it and then I put control A. I remember somewhere. Oh no. Should be BG. Okay, pickle. Come on. Now I have to exit out of it, so I put control A. Oh fuck me, I exited the count. That's just shit. That's just shit. Hopefully the Temex is there. Okay, it's there. How to get the queue status when this is running. Let's see. Control A and C, okay. Control A, C, nothing happened. Control A, C, nothing happened. C, nothing happens. Mac, Control A, maybe it's Control Shift A, Shift C. A does not work. No, I don't want to add anything extra. Currently I'm running it as what modes? Non-graphic. Okay, whatever. So I'm gonna already have see now the entire thing is going to this. Oh, port is already in use. Okay, suppose use 78. 78 should not be used. I need permission for that fucking thing and use 7899. Okay. I don't have telnet, I'll just put NC 7899. just have to put this. Okay, now I have the camo. Now I can should be able to run this command. What the crap? Okay, let's put the info and with your status. Holy fucking moly. Path to your fucking device. What the fuck do you mean by that? Maybe then I'll just put in for which IO. Okay, this is my device. Okay. So I just have to take this and paste it here and change it to a non-device one. And device name is device ID is 2. Q select is 0. Well, it has given a lot of stuff, but still it did not answer my question of if I can see the status of what's happening here. What do you mean? How do you know my request is sent properly? Your request is sent because device data register shows. That's because I said that device has been found. Is there any way to any log mode? To show requests. No, from here. Just turn it. Hopefully it did not hallucinate. Let's see. Can we get all the help commands? I want to see what is in the queue. Okay, so this is the queue 0. Queue index is 0. See, the descriptor is not updated. I guess that's the issue. Looks like descriptor is not updated. Both descriptor and used, both are not updated. Why the fuck? It should be. Let's check these two operations, because what is updated is that avail is updated, but descriptor and used is not updated. Okay. So how do I confirm if it gets updated properly? I need to know the proper register that it is using. This value is not getting updated properly. You can actually use these to actually check that. This is why we need some sort of debugging, so that we know what is wrong, because there's no way to manually figure this out. We need some way to see what's happening and then take it from there. Somehow we figured out this monitor method, and we were able to actually print the settings that the current index is configured. And as you can see, the avail has C7 something, but descriptor has nothing. One thing we can do is let's try to print printf setting avail with and we can put which.io objects which.io physical avail. Now that we can print it, now we bash it, continue. Let's see. Setting avail here. We take that and we come here, we put it here, and we convert it, and it's C7000. And if we connect to that server and paste this, hopefully the name does not change. And it is C700. Let's just check one more thing, why it is not. Maybe then the actual value here is not correct. This looks like the right operation seems to be working just fine. scale it, build it, run it. And if we scroll, looks like the whale has something. So maybe it's just the right operation that's not working. Because if we come down and we check this, we definitely have this and it is there. But it's just simply not able to write. Why is that? Because we have U32 and it's which IO descriptor low and descriptor high, and we are using the same lower half and upper half. Let's just check one thing. If desk low my mode device layouts and descriptor low, descriptor high. Avail is 90 and 94. Used is this. I think I just confused and wrote the legacy value here. Looks like that. Yeah, I have written disk low. Disclose 50, but it's 80 here, so probably that's the thing. Yeah, I think that is it. We just have to properly give the values. If not, we can't expect it to work. And disk low is, I think I just copy pasted it and I did not update it. Fuck me. 84, 90 and 94. Avail device low is A0 and it's A4. Okay, let's see. Let's build it, run it. No, at least let's see if the values are updated. If we don't get anything, at least we can say we have managed to write it properly. Okay, now the values are updated, so we have the register correct, and last avail index is 0. I don't know if it worked or not. Oh shit. Nope, it did not work. ATX strings. Yep, it did not work. Okay. Well, at least we managed to go through one step. That is, right now the values are there. Now we have to think about what else could have gone wrong. Okay. Now the registers are in place. What else could be going wrong? Well, if it has completed, if I run strings command in the image, I don't see the string there, so definitely the operation is not complete. So unless, so I mean, but the interrupt will be triggered after the write operation is over, right? So even if I don't handle the interrupts, if the request was processed, I should see the string in the image when I run the strings commands. Okay. Can we make it directly right to the block so I can test this without having to handle the interrupts? Is this even a option? Sometimes it will just fucking hallucinate. Let's just search it. Looks like it is something that is. Hopefully, it's not deprecated by now. deprecated. And we have device format HD and this. Okay, let's see. Let's see if we are able to manage to write. But I don't see the status bit updated either, so I don't know. I don't fucking see it. Nope. It's not here. It is not fucking here. Oh, fuck me. Okay. Let's see. Let's run this. Maybe we'll have to finally handle that. There's no other way around it. What? I got an extra message here. What is this? Okay, we can handle it. I just want to first of all confirm if my first write operation is working, and then I can deal with the interrupts. I don't want to deal with the interrupts and then the fuck. I don't want to deal with that. Length field set to 0? How is that possible? Where's my length? This is size of this, and this. How is it 0? What the fuck do you mean by 0? And it's after 5. Okay, when I notify it, I get this error. Oh, let's remove this. Let's set this to 0. What else did we fucking change? Did we change anything? How is that the length is 0? Can we see the descriptor in the camera values in the camera monitor? Okay, looks like it is possible. Let me run this, and then I run this. I put this. That memory is just 0. What exactly am I expecting in that memory? Huh. If this memory is just 0, probably that's the issue. Let's try 7 and 8. 7, 0, 0. What the crap? Okay, 7 has a value in it. So maybe there is something wrong with the write operation. Let's see if we have the values. And if we run it, 7 is there, but 6 is not there. Let's see, 1, 2, 3, 6, 1, 2, 3. Because it's just pointing to 0. Why is it pointing to 0? What the fuck did I write there? Oh shit. I equals 0. Oh, it's always my own faults. I just fuck up things. Status queue, what did I do to it? Okay. No. I think it should get better. Okay, the values are there. Still the used index is not updated. Or maybe it is updated, I don't know. But we haven't handled the what's that? The interrupts, so it shouldn't be handled. Let's see if there's anything here. Nothing is here. Okay, what else can we check? Oh, we have to check the actual value inside that. Not just the address. we run this, and we run this, and we run x3 gx 0x c123 6123. Okay, I believe we have it. Length is probably this value, and then we have flag. Mm-hmm. 700, and 700 has the descriptor, and it has an address. Address does not seem to be right. If something is wrong with my implementation, not the overall flow. I just fucked up the locations. I think that's the issue. I just wrote it to the wrong locations, because for the first value we have an address here, and the second address is 64-bit, so this is going to take the entire thing. And then we have a 32-bit, or is it just 32-bit? What the fuck am I writing there? If we go back here, for descriptor 1, its length and un32. But it should be automatically converted. I don't think I have to explicitly mention this. I have the kernel address, I have the length, and I have the next, and I have the next field too, which is 1. Let's put 5, 16 gx, 0xc, 1 to 3, 6, 1 to 3. Oh, fuck it. There's some fucking error. Probably I just missed some. So I can't write just 16 bytes. Just have given it as 16. Okay. Okay, that's one issue. So I just allocate 512 and write to a little bit of it, and then give 512 here. Okay, let's see what happens now. X 16 gx xc 1 to 3 6 1 to 3. Is it better now? I have written 512 bytes to it. I'm not writing 512 bytes, but there's 512 bytes to be written. That error was long gone. Nope, did not work. I'm actually writing into which sector? 100th sector. What the fuck am I reading? 100 into 512, yeah, I should be fine. Maybe we can check 99 into 1024 just to see if we have any off byte errors. No, it's just full of zeros. Well, let's see one more thing, if the actual buffer is readable. Let's run this and connect to it. Probably this is the address. And I think we can put instructions, characters, I guess C, or ASCII string 0x C123 C123. I guess I have to just use XC 123. See, it is there. So what else can I check? Still, I don't see the right operation succeed done to the block. Okay, what else can be going wrong here? Are you fucking sure? Find an article to show this example. Flow of flags. I don't believe you. I need extra. That is 1.1. Oh, does the descriptor 3 next field has to point to anything? But I am setting next, right? Or am I not setting next? I don't know. Okay, so I set next. Okay, maybe I'll just remove this. Remove this right then. What else? I think it should be. Let's try. You'll never know. Why does it say descriptor next is 1? Get this message. Okay. Mm-hmm. 100th sector. I don't get that block for the next descriptor, which is 2. I think I just have to fucking figure out if the value is if this flags are correct. which queue data. So we need to give both the things here. Which queue, I mean, depends on the mode. If it's right, we have to give the right here. And finally, and we chain the indexes. First index dot next will be D2, and D2 dot next will be D3. And then we write the queue. That's exactly what the fuck we did, but probably we did it in a really messy way. Okay, let's just see, figure out why this layout is not working. Looks like you're not writing the proper flags. Okay, let's check that. And I don't have charge. I'm almost fucking done. Okay. Okay, guys. Today, guess we managed to at least debug a little bit. We are able to see that we have written the registers properly, and we have also prepared all the requests, and it's fully ready, and we have also updated everything. And once we move past this status, we should at least see the strings updated. So yeah, we'll debug this tomorrow then. Have a good day, guys. Bye bye.